Hello, Assalamualaikum, ladies and gentlemen. These are group members, myself as Haseeb Khawar, then Usama Ejaz and Fasih Hassan. Thank you. As for the topic deadlock, each of the group members have been assigned with some certain topics to explain the details of deadlock.
Introduction to deadlock. A deadlock is a situation in which more than one process is blocked because it is holding a resource and also required some resource that is acquired by some other process. Therefore, none of the processes gets executed. If two or more processes are waiting for happening of some event but that event doesn't happen, that is called deadlock, and those two processes are in the deadlock state. For example, in bank to open an account, manager says that we have to deposit some particular amount. Let's now talk about deadlock characteristics. When a deadlock can occur? Well, a deadlock can occur if these four conditions occur simultaneously. Number 1, mutual exclusion. Number 2, hold and wait. Number 3, no preemption. Number 4, circular wait. So these are necessary conditions. Mutual exclusion is first characteristic of deadlock occurrence. This says that a resource cannot be shared to more than one process at the same time. In this scenario, the resource must be used in a mutual exclusive way. No preemption is second characteristic of deadlock occurrence. It says that the process which once scheduled will be executed till the completion. No other process can be scheduled by the scheduler meanwhile. Third deadlock characteristic is hold and wait. A process waits for some resources while holding another resource at the same time. As you can see in the diagram, P1 is holding resource 1 and waiting for resource 2, whereas P2 is holding resource 2 and waiting for resource 1. It holds resource and wait for another resources. Circular wait is last characteristic of deadlock. Circular means there is a loop in this. If there is a loop, so definitely deadlock situation can occur here. All the processes must be waiting for the resources in a cyclic manner, so that the last process is waiting for the resource which is being held by the first process. So let's look at the diagram. P1 is holding resource R1. For hold, the direction of arrow will be outward.
So I'm starting with very basic level, like what is deadlock, and further on are leading light on two of its approaches. Mainly there are four approaches to deal with deadlock conditions, and I will show you two of them. Okay, deadlock is a situation where a process or a set of processes is blocked, waiting for some other resource that is held by some other waiting process. It is an undesirable state of the system. In the deadlock ignorance method, the operating system acts like deadlock never occurs or completely ignores it, even if deadlock occurs. The method only applies if the deadlock occurs very rarely. The algorithm is very simple. It says if the deadlock occurs, simply reboot the system and act like deadlock never occurred. That's why algorithm was called hostage algorithm. Now it's time for deadlock prevention. As per saying, prevention is better than cure. So, the strategy of deadlock prevention is to design the system in such a way that possibility of deadlock is excluded. Like in direct methods, prevent the occurrence of one of three necessary conditions of deadlock, like mutual exclusion, non-preemption, and hold and wait.
Welcome, ladies and gentlemen. My name is Khawar, and our topic of the presentation is deadlock, and my co-presenting members have explained the details before, and now I will conclude the topic. First of all, for deadlock, there must be a circular weight. But to remove the circular weight means if we want deadlock should be prevented, there should not be a circular weight. Means we are trying to remove the conditions of circular weight from the system, giving the numbering to resources and condition. Now, deadlock avoidance. Deadlock avoidance means that how to avoid the deadlock being happening. That it means we are trying to give the resources to the process, and whenever we give the resource to the process, we will check whether it is the safe situation or not. When we give a particular resource to a particular process, so we check deadlock would be avoided or not for every resource allocation. We check the safe and check deadlock handling, you can say the deadlock detection and recovery. In this, we are trying to detect the whether there is a deadlock or not, and when we detect it, then we are trying to recover our system, that we remove and then move on to the next step. Detection and recovery of a deadlock is complex. Thank you, ladies and gentlemen. That is for today. If there's any questions you want to ask, you may ask. Or thank you for your time.